Again for joining. A little background on Soilgenic. As mentioned, our vision is to reduce CO2 emissions and environmental impact. My name is Jeff Ivan. I've been in the industry for over 32 years. Half of that on international business. We come from a family farm in Saskatchewan. I've been involved with retail, manufacturing, and international business development in both emerging and established regions. Sat on many committees, from the Environment Agronomy Committee to the 4R and Sulphur Institute, developing the sulphur market in India. Our chairman of the board, David Berg, he was director of Potash One. Prior to that, he was the VP of operations with one of Canada's largest food company, and he is involved with several other projects in agriculture. So as you know, the problem is the global food chain needs to change to become more sustainable. Consumers are demanding more wholesome foods. Soil health is a concern. Concern over nutrient loss to the environment, and of course, CO2 emissions from agriculture. This is an overview of Soilgenic. We're focusing on primarily green ammonia technology. It's a $81 billion agricultural opportunity, but you can't talk about reducing CO2 without talking about environmental nutrient loss. And we're also bringing in a new technology that will lower the cost of nitrogen stabilization by 50%. Currently, it's $1 billion market, moving to $5 billion. In terms of the energy industry, green ammonia will play a very important role in storage and transportation, as well as a direct energy source. And that will, as you see, is a pretty considerable market that is being predicted. Finally, Rng Production, our sister company, is producing Rng technology. We're looking at sustainable fertilizer production that can reduce a significant amount of CO2 emissions from the environment. So plants need nitrogen. All nitrogen starts off with the Haber-Bosch process that was developed in 1909. You look at anhydrous ammonia, urea, UAN, they all start with the Haber-Bosch process. And it's a very important process to agriculture because over 50% of the population today relies on the synthetic production of nitrogen. The problem with the conventional ammonia process is that ammonia is very carbon intensive. As mentioned, you're looking at 500 million tons a year of greenhouse gas emissions. And the solution to that is green ammonia. Green ammonia is produced from renewable energy using the electrolysis process. But the challenges with green ammonia is it's 3 to 9 times more expensive than carbon-based ammonia production. And the electrolysis ammonia technology is inefficient and difficult to scale. Our Chief Technology Officer has several patents to his name, and he developed the patented structured catalyst technology that was a breakthrough technology with his previous company. He partnered with Dr. Stephen Chu, the former Secretary of Energy with the first Obama administration, to develop the carbon capture technology. And we're using his structured catalyst technology to develop our green ammonia solution. And this is just a little bit of the challenge behind electrolysis. As you can see, the Department of Energy, the green line on the left, shows the target level. And if you look at all the different types of technology, the production is extremely slow. And if you look on the right, the current rate of efficiency of different types of catalysts, including rare earths, again, a very poor efficiency. If we look at the catalyst challenge, we feel that one of the biggest areas overlooked is the active surface area for the reaction to occur. And this is the space that we're currently looking at within Soilgenic. So the solution is our Intensify electrochemical process. The technology will simplify and increase the production of green ammonia. The medium is extremely reactive. If you had a sugar cube size of the reactive material, it would have a total surface area of a football field. The result is efficient, structured, and highly reactive process that results in the intensification of the ammonia, resulting in a smaller, faster, and more economical production of ammonia. And this is what it looks like. If you had a stacked layer that looks like a filter, you would see areas where the air can pass through. And if you look at it closer under a microscope, you would see bonded active particles on the conductive materials. And of course, at a nano level, you would see the bonded materials. If you think of the active material like a microchip, it's designed to handle the electrical load and also the efficient movement of electrons through the medium. So the breakthrough is the intensification process. And if you look at the production, a 1 meter cube cell would produce about 60 kilograms of ammonia. This is a prototype concept that would produce about 50 metric tons per day. And one of the chief benefits is the capex and opex are significantly lower than the Haber-Bosch process and green electrolysis technologies. So we're looking to optimize the process. We're at TRL level 6 today, and over the next 12 months, we'll be optimizing the technology. One of the benefits is we can use green ammonia for renewable energy, but also we can look at natural gas using carbon capture to decentralize ammonia production today. So in the energy side, there's tremendous opportunities with ammonia. The reason is ammonia is 1.8 times more concentrated than hydrogen. It stores easily, it transports easily. You can see on the right side the density of ammonia compared to hydrogen or even the batteries. The Tesla or the Corvus battery shown, you're looking at 9 times more energy dense than lithium-ion batteries. As a direct fuel source, ammonia is going to be looked at for heavy industries on farm as fertilizer, but also as energy on farm, powering tractors, combines, as a clean energy source. The ocean freight industry has already committed to using ammonia. So that as a result, you'll see a considerable increase in the requirement. Today, we're at 180 million metric tons of production. And with the shipping and power and storage of hydrogen, it's predicted to increase to about 660 million metric tons, which is about a $230 billion market. Today, we're looking at raising a $2 million seed, and in 90 days, we'll be moving to a Series A for $5 million. We have near-term revenue in our forecast with the nitrogen stabilization technology, which currently sits at just under $1 billion, and with pretty significant returns on margin. Thank you.
Great, thank you. I think actually you made it just in time, which is perfect. Unless anyone has any questions for Jeff, there is a 5-minute break between now until 10:10, where the panel discussion on opportunity in conversions will happen on the main stage. No questions in the chat or in the...
Yeah, they could reach out to me after. I believe my profile has my email address, and we're currently in discussions with both agriculture and energy partners to join us. And we have pretty strong interest because of the technology having a significant impact on green ammonia production. So, yeah.
Great.
Excellent.
Thank you, everyone, for attending the session, and see you in a few minutes on the main stage.
Thank you.